Sorry,
No worries.
my internet decided to crap out.
I think we're able to figure out 8 and 9 though.
Sorry, guys.
Okay.
My internet decided it did not want to work anymore. I'm sorry. What were you saying, Tyven?
I think we figured out 8 and 9.
What did you guys think? Sorry. I stopped looking as soon as it bumped me.
Eight was the first one,
The
and
great.
nine was the second one.
Thank you. I'm sorry, guys.
All right.
Okay. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim was about $1,500. They're concerned that the true mean is actually higher than this. Use this information for the next two questions. Which of the following would be the appropriate alternative hypothesis, or HA? This one, right?
Sorry, I'm still.
That it's greater than? Right, because the alternative hypothesis is what they think it is. Is that right?
Yeah.
Okay. Which of the following would be the appropriate null hypothesis? The first one, right? That it's equal to?
Yes.
The insurance company randomly selects 40 claims and calculates a sample mean of X bar equals 1650. Use this information to answer the next three questions. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? Is it the first one where it's a large sample? What theorem or law justifies your answer to the previous question?
Central limit theorem. I can't remember what law of large numbers is though. So
And
Yeah,
that's what I was just looking.
So why is it central limit theorem?
I thought that's what it was because if the sample size is large,
Mhm.
then we can assume that the sample is normal, which would mean that the sample mean is normal, right? Because the law of large numbers is just that as the sample gets larger, it's that the sample mean is closer to the population mean.
Oh,
Is that
yeah.
right?
Yeah.
So this is something, maybe I have a little clue. I don't know, you're probably right, but I wrote down when he talked about the law of large numbers and the central limit theorem, he said the law of large numbers applies to the mean. So it's talking about how close something is to the mean and the large numbers associated with that. Central limit theorem, he said, was large if there was more than 30 in a sample is large, and that no matter what, so you could have 10,000, I mean, you probably saw that, but you could have 10,000 people and only sample 30, and it still would be the central limit theorem because anything over 30 is considered a large sample. But the central limit theorem has to do with the spread and the distribution. So if it's talking about spread and distribution in the question, then you're probably going to be correct if you say the central limit theorem.
Okay.
Does that make sense?
Yes.
But that the word large is confusing when it comes to the large numbers in the central limit theorem because
Yeah.
it's not really large necessarily in the central limit theorem.
Right.
There, that's my contribution this week.
Great job. Awesome.
Okay, which of the following is the test statistic as defined in this lesson? It's this one, right? The X bar.
That's what I think.
Where you got higher than me on the test, I feel confident with. Like, if you're saying it's good, then I'm good with that. Okay. Historical mean of sales receipts at a grocery store is $150 with a standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the hypothesis null equals 150, alternative equals less than 150. She will use a level of significance of 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes X bar equals $144. Use this information to answer the next 4 questions. Excuse me. What is the Z-score associated with the test?
Question 15 is just that we've been doing. Finding that Z-score.
But it's the one with the square root, right?
Yeah.
I got negative 0.9. What did everyone else?
1 second. I'm almost there.
Oh, you're fine. Sorry.
Yeah. Negative 0.9.
See, now this is where I'm going to struggle. What is the p-value associated with the z-scores? Is that just, we put it in here?
Yeah, we put negative 0.9 into the applet and find what's below that.
And it's this number, right?
No.
No.
0.9 is the Z. Well, yeah, the answer would be that.
The
There.
0.1.
Yeah.
Say to round it down. Okay. So the 0.184 then.
How'd you get negative 0.9? I messed up my math somewhere.
No, you're fine. So I did 144 minus 150
Yep.
over 40 divided by the square root of 36. Because we knew
Oh, okay, that's where I messed up. Okay, got it. Okay. There you go.
okay. What inference would you make about the null hypothesis for this problem? See, and where I just read it this morning, I'm not totally, we calculate it by finding the error. So if it's low, we reject the null. Would that be considered? No, right?
So we have the p-value,
Right.
and then we have the what is it? The level of significance, which they gave us, was 0.05. So then we have to compare those two numbers. So the p-value is greater than sigma, which means that we fail to reject the null hypothesis.
Why can't they just say accept? Like, too many words, just take out a few. Like
Got me.
Mozart, too many notes. Or what's the movie? You guys probably have never seen that.
That makes sense how that works.
No, I'm just trying to remember.
Don't worry.
So if the, that's what I think of it. Is it because it's bigger than alpha? Is that why we reject it? If it was lower than this number right here, then we would,
No,
huh?
the third part says if the p-value is greater than sigma, then we cannot reject the null hypothesis. But if the p-value is less than sigma, we do reject the hypothesis.
Okay. That makes more sense. Sorry.
No worries.
So for that, we have sufficient evidence that the true population mean is 150, right? That was the null hypothesis.
And actually the third one, we have insufficient evidence that true population is less than 150.
Okay. So what's the difference between that then? How would we have sufficient evidence that it is true?
That's because we haven't proven that the true population is 150. We can't just accept that. We
Oh.
have to, we can say as a fact that we don't have enough evidence to say that it's less than.
Okay, that makes sense.
Mhm.
Thank you. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? I did that. That's the type 1, right?
Yeah. type
Yeah.
one.
Okay. A researcher decided that instead of using a level of significance of 0.05, he will use 0.01. Which of the following will be true? The probability of a type 1 error will increase. The probability of a type 2 error will increase. The probability that the null hypothesis is true will decrease, or his experiment will be more scientifically valid.
I think it's the first one, but I'm not super confident on that one.
Should we phone a friend? Ask the audience.
I wish that was true or possible.
Well, if my boys went to go get batteries for my calculator, so they're not here, I would ask them. They know this stuff.
I'm just trying, there was a question on the homework, so I'm trying to find it.
Well, it's either the first or the second one. So you can change it if it's wrong.
No, you're good. I'm just. I think it was type 1, because so in part 2, it was saying if the analysis, sorry, part 2, 9C, it says if the analysis was done at the alpha equals 0.01 level, what's the probability of committing a type 1 error? And it's there, it'd be 1% of getting a type 1 error. But I'm not sure if it's just because of the way that that's written. Oh, if you wanted to decrease the probability of making a type 2 error, would you want to increase or decrease the level of significance? You would want to increase. So if you, so then it's the opposite, right? If you decrease the level of significance, you increase the probability of a type 2. Right?
Maybe.
I don't know.
We decreased the value of significance. So what does that mean?
Over here. What was the question again? I'm sorry.
So we decreased the level of significance.
Did that go to any of the, did that go to here, or was that just a separate question?
No, that's on 20.
But yeah, well, in the question, you're decreasing from 0.05 to 0.01, right?
Yeah.
Right.
Okay. Hey, naughty girls. Hey, go to timeout. Go. Both of you. Go. Go on. No, I don't need you to tell me that the brown man is here. I'm sorry, the UPS man is here.
You're fine.
Go. Go.
Well, if we know it's one or the other, I'm okay with going with either. We can guess the other one if it's wrong. Okay, if A equals 0.05, compute the probability of committing a type 1 error. Oh, good night. How do we do it again?
Compute the probability.
My babies are in timeout.
Uh-oh.
The UPS man comes with a brown truck. I don't, what is it with the brown uniform and the brown truck? I don't understand. Come here.
You guys remember how to compute that? I am so sorry.
Bella, come here. Okay, good girl.
Maybe it is just 0.0.
What? Sorry.
Maybe it's 0.05.
Is that the 0.05?
I think so.
Let's see. And if it's wrong, then I'll go looking for it. Okay. Sorry, I'm just, as I go, I'm gonna enter these in.
Oh, did I miss something? I didn't see what we got wrong.
We haven't yet. I'm putting in the ones that I know we got right as I go, so hopefully it doesn't take as long for you guys. Did I have that backwards? Apparently.
Oh, you're going way fast. I'm not seeing which ones are
Sorry.
changing. So 6, 7.
Sorry, I had the first one on 6 and the second one on 7.
Okay, I mixed
Okay.
up. That was my bad.
Well, those ones are just confusing. to know
Yeah,
Which side is right? They're also similar.
I will go back over too, I promise, at the end and go slow.
What other ones did we get wrong?
I will go back. Sorry, I'm like half asleep right now.
Oh, yeah. Well, it's like, my in-laws coming in town and I said, "We got documents."
So
Z,
is it Z?
it's Z.
Yeah.
I help if I went back.
I hope.
Okay. 15.
Well, I'm glad to see we got most of them right.
Oh, yeah. I missed one. Yes, I did. That one we just weren't sure, right? So we just try.
Yeah. Try the
Yeah.
second one.
I need to watch the video explaining the homework.
Me too.
Okay, let's see how that one goes then.
I just had that we missed 4, 6, 7, 14, and 20.
Yes, 6, 7, 14, 20.
Okay.
So we got 100% on it, that one. Good job. I'll just go down to where it's actually the questions and I'll just slowly scroll down those and excuse me. Can you hear my kids yelling at each other in the background, or are they far enough up you can't? Okay, good. They're mad because the internet's turned off, so there's no TV. Well, there is TV. I just didn't want to take the time to turn it off and get an actual movie. Did I send you, Anthony, did I send out the one the video from yesterday?
Yes, I got that YouTube video.
Okay.
You're good.
I feel a little bit like my brain's mush, so I just wanted to make sure I did actually.
You're fine. Thank you for being the host of all these.
Oh.
Yeah, thank you.
I totally
I
don't.
know.
it's
Well,
super-
I thought today was gonna be a problem for you, so you ended up staying home and,
I did. So, I had allergy testing on Friday and some of them I've reacted more severely to. And so I've kind of got sniffles and stuff. And so I'm like, oh, I'll just stay home. And then, my husband went down with his dad. So it was like a boys' day for my son. He was okay with that because it's usually my oldest who gets those. So he was good with it. I don't think he's even said hi to me since he got home. So apparently he didn't miss me too much. So- Okay, that's it for today. So
oh,
I'll get that uploaded as well as like the 5 minutes before my internet bumped me. So I'll get those uploaded and good luck y'all on your tests.
All right, Cindy. Good luck, Cindy.
thank you, you too, Anthony.
Yep.
I guess we'll see each other on Monday.
Yep.
See you guys.
Thanks, guys. We'll see ya.
Bye-bye.
Bye.